All right, we are jumping forward from Hume about 100 years or so to John Stuart Mill and his account of causation, which is in his System of Logic. Mill divides the laws of nature into two kinds here. One governing simultaneous events, and in that class are the laws of mathematics and geometry, so he calls those laws of nature. Interesting, right? Um, So, various objects in the world stand in spatial relations to each other. We use geometry to describe those relations, right? And the laws involved in that, Pythagorean theorem or whatever. Um, and likewise, mathematics describe the addition, subtraction, division of various objects. Um, I don't know if he's talking about governing style. I don't know how he conceives of right, these sort of mathematical simultaneous laws, if these things are governing laws or just descriptive laws. So I'm just using this descriptive. It doesn't really matter because the point of this book is about the other types of laws. So laws of simultaneity don't require a variable for time. They apply to objects in a given instant. For us these days, they're not even the kinds of laws we would call laws of nature, right? They're mathematical laws. We typically think of them as a different thing. Mill is sort of thinking them all those laws of nature. So, this is just what he says. We tend to think that they're in a different class from scientific laws. Um, Mill appears to disagree and seems to think that the laws of mathematics are empirical laws, just as other laws of nature are. Um, you know, we tend to think of mathematics as necessarily true, holding in every possible world. Mill doesn't seem to necessarily think so, I guess. Um, so interesting. I don't quite know what to make of Mill's approach to laws of mathematics. If you wanted to write a paper on it, that might be interesting. But fortunately, we don't have to delve too much into whatever analyzing Mill's, historical approach. Instead, we can move on to the his account of causation. So, the laws of nature that we've been concerned with, Mill would call laws of succession, right? And they're kind of most relevant to us because we can use them for our benefit. Not that mathematics and geometry are useful, right? Um, but typically they're the most useful when they are applied to problems that involve the laws of succession. So laws of succession for him is, anything that involves a time variable or anything that involves over time, right? So things that we can predict, right? Laws that we can use to predict and manipulate the world around us. Um, Example, if you know the laws of moving bodies, right? If you know the Newtonian laws of mechanics, then a little geometry, you can figure out where a cannonball is going to land. And, in the 1800s, that sure can come in handy if you're trying to conquer a city. So the goal of our laws of succession would be, it would be nice if we could find laws of succession that were as certain as our laws of simultaneity, right? So we've got a pretty good grip on the basic laws of math and geometry, right? So if we could get our other laws of nature on that solid a footing, that would be pretty impressive. Um, but it's really hard to do that, right? It seems like all of our laws of succession have exceptions, right? So, you know, uh, objects fall towards the Earth at 9.81 meters per second squared is not always true because if I drop this phone, it might start to fall, right? But then it might get caught, right? Or somebody might kick it, or a very strong gust of wind might blow it some direction. Or other objects, which are lighter, like a feather, the air resistance will cause them to fall at a slower rate, right? So there's all these sort of exceptions, what we call ceteris paribus clauses to our laws of nature, right? Um, so there really only seems to be one exceptionless law of succession, which Mill calls the law of causation. Every event has a cause, and that cause, although he'll get into later whether there could be simultaneous. Uh, okay, so he says it'd be nice, right, if our laws of succession were as certain as mathematics, but it seems the only candidate is the law that everything has a cause. So what does he mean by causation? Um, so first of all, he wants to, philosophers in particular, heading up to Mill's time, used cause in a lot of different ways. People would talk about God as the first cause. Mill says, I'm not talking about that kind of causation, whatever that is, right? Whatever causation is involved with God. Um, Aristotle famously had like, I want to say, five different types of causation, um, right? Formal causes and all, and that's not what he means. He means cause in the more sense that we mean it these days, right? Um, and he's not necessarily talking even about, he's not so worried about what Hume was worried about, is whether there's necessitation, right? And what is this necessitation, this mysterious force, whatever, this governing force. He says, I'm just talking about causation as it's presented in experience, right? Um, but he thinks it's presented in experience as invariant, right? That causes always produce their effects. Is cause Y's. Anytime you have an X event, you will have a Y event. Um, and of course, we don't experience that, but we do seem to sort of import that into our experience of cause for some reason. We talked about a lot when we talked about Hume. So, how do we capture causation and the fact that, it's supposed to be invariant, right? Causes are supposed to always produce their effects, and yet in our experience, that's not always the case, right? So a single event type does not always produce the same sort of effect. So striking a match typically causes a fire, right? And you would want to say that striking the match caused it to catch on fire. Um, but there's just lots of times when it doesn't happen, right? So the match might be defective. A strong wind might blow, as soon as you strike it. That happens all the time, especially outside if you're trying to light a birthday cake or something. There might not be enough oxygen in the room, right? If you're in space, it's not going to light. Um, so how do we make sense of that? How do we offer an account of causation that makes it invariable and yet takes account of the fact that in everyday life it's not so invariant, right? Well, I mean, if I asked you, right, why did the match not light this time? You can invoke all sorts of conditions or states, right, that weren't present, right, that would have been necessary for the match to light. So you can say it was too windy, right? You need it needs to be calmer, right? The atmosphere. There needed to be oxygen. I was in space, there's no oxygen, right? And so on. So all these other states that sort of needed to be there for the effect, for the cause to produce its effect, um, Mill says those count as causes too, right? The whole set necessary conditions is the cause, right? And the idea is like if you name all of those, then you do get the invariance of effects following their causes, right? So say a match struck in an area with sufficient oxygen, right, with a non-defective head on a sufficiently, friction on the surface, with a sufficiently calm atmosphere. If you can name all those necessary conditions, right, that would rule out all of the exceptions, then yeah, every time you struck the match under those conditions, it would light. So that means that a cause is not just a single thing, it's a whole set of individually necessary, but also individually insufficient events, states that are jointly sufficient for the effect. So now, um, states, right, are things like having a calm atmosphere or whatever event of the match and so on. So human nature is such that we tend to think, well, the most recent event, the sort of closest to the effect, that's the cause. Um, but Mill says no, there's lots and lots of causes. Um, so, if whatever the rotation of the Earth is a part of it, right? Then yeah, that's a cause too, right? Stuff that's been around forever, um, right? The atmosphere being such as it is, uh, that can all count as a cause, right? Just because it wasn't very close to the event doesn't mean it wasn't a cause. So as an example, right? So, suppose whatever 100 people are voting on the student council president, and I cast the 51st vote, and that puts my candidate over the top. People will sometimes talk as though, oh, Nate was the cause of her winning, right? But, according to Mill, my vote is no more the cause than the first person's vote, right? Even though temporally it was much further back than mine. Um, how close the cause is to the effect is does not matter for me. We started, if you recall, this was sort of right when Trump took office, and there was an attempt to repeal Obamacare, and John McCain cast a vote that prevented the Obamacare repeal, and we got exactly that sort of talk. Like it was McCain caused the bill to fail, and he kept Obamacare alive. Um, but no, there was a lot of votes, right? His was one of many. So his vote was no more the cause than Chuck Schumer's or any of the other people's, right? It was just the one that revealed the ultimate outcome. It was temporarily the closest one. So again, a cause for Mill is a whole set of events. They're all necessary, right? So for each of them, the effect would not occur if any one of those was missing. Um, but any one of them on its own is not sufficient. The whole set is. So another example that he uses is of the Sentinel, right? So sometimes we say stuff like, "Oh, the army was surprised and defeated by the enemy because the Sentinel fell asleep." But again, that's just one member of this whole set that is the cause, right? So, the Sentinel didn't create the enemy army or command them to go attack the position. He didn't cause the other soldiers to be asleep, and so on, right? So when we say stuff like that, oh, the Sentinels falling asleep is what caused the army to lose, what we really mean, according to Mill, is that if he hadn't fallen asleep, um, they wouldn't have been defeated, but you could say that of all of the other factors as well, right? If they had not been commanded to attack, if the enemy army had not been commanded to attack, then also our army wouldn't have been defeated. Um, Now, some of these factors makes a distinction between positive factors and negative factors. So the positive factors here are the enemy army attacking, right? Um, the sentinel is sort of a negative factor, right? It's the absence of a functioning sentinel that also contributes. Um, but positive or negative, the whole set is the cause. Now, this means that if you want to say what caused an event, it's almost impossible to say because, right, think of all the negative factors that are involved, right? Um, there had to be, right, there had to be not be a spontaneous wildfire in that moment, right? The all these lots of people had to not have heart attacks at that moment, right? And so on. Like it's pretty much infinite the number of negative factors that are there, all the things that didn't happen, right? But what we can do, right, is capture all the negative factors by what we call ceteris paribus clauses. So when we say a cup knocked off a table will ceteris paribus, I think it's cause the cup to hit the floor. What that means is like, yeah, all else being equal, you knock a cup off the table, it's going to hit the floor. Now, of course, you could jump over and catch it, right? The wind could blow it. Well, that's what the ceteris paribus clause is capturing. Saying, so long as somebody doesn't catch it, or the wind doesn't blow it, or the other infinite number of negative factors, um, the cup will hit the floor. So even though there's potentially infinite number of causes here, particularly the negative causes, we can sort of all put them all in a ceteris paribus clause and we can mostly concentrate on the positive factors. So for our purposes, then, this isn't the strict definition yet, but so far, the cause of an event is the set of all the positive factors which invariably produce it. All those positive factors are present, ceteris paribus, all the negative factors. You're, okay, so he considers some potential objections. So if the if the cause of some event, whole big set of necessary conditions, you might worry that it's possible to distinguish the cause from the effect. Right? For example, if we ask what caused a stone to fall, some of those conditions will include properties of the stone itself, right? Its mass, its weight, its consistency, and so on, its nearness, its position vis-a-vis the earth. Um, so when you say what caused the stone to fall, all these things about the stone, are we saying that the stone caused itself to fall? And would that be contradictory? Because aren't causes supposed to be effects? Um, Mill says this is just a kind of a merely verbal worry that arises from the fact that we tend to ignore states as causal factors, and we focus on events, right? Um, so we kind of tend to focus on agents and patients, right? The people doing actions or the things doing actions, the things receiving the actions. And we say, well, one of those is the cause, one of those is the effect. But states are just important, right? Just the presence of oxygen, the over mass of the stone, and so on. And if from the beginning we had all been sort of proper millions, million meaning like followers of Mill, um, and we'd been thinking about all these myriad causal factors, including all these states, then we wouldn't be so hung up on worrying that the rock was causing itself to fall. Of course, the properties of the purported effect are also very important, right? So, for example, he says, look, the light hitting my retina is no more the cause of a visual sensation than the various states of my visual system, even though you might consider those part of the effect. It all matters. So, Mill is not a regularity theorist, right? Like Hume. So, a cause for Mill is not just the set of factors that always has, so far as we have observed. If that were the case, then we would have to say that day is the cause of night, right? Because night has always invariably followed day, as anyone, any human has observed, right? Um, Rather, a cause has to not just hold our experience, but in sort of every conceivable experience, right? Um, and we can imagine a situation in which night would not follow day. If there were imagine there were two stars, right? And there was the sun, and kind of like on Tatooine, right? We had two suns, and if they were arranged such that there was never night, right? Then okay, the day would not follow night. Or if there's just a big enough light, or if you're at the North Pole, right, or something like that. Um, so his point being, um, it's not just about our experience, but we have to think more broadly what's conceivable. But this is a little worrisome, just the way he phrases it. Typically, when we talk about what's imaginable, that's usually a criterion for what's logically necessary, right? So we say, I can't conceive of a round square, right? That's logically impossible. And so we would say, okay, circles are um, necessarily round, right? Um, but again, we're not talking about like mathematical logical necessity. We're supposed to be talking about um, the smaller end sort of necessity, like within our universe, right? So usually what you can imagine is not the proper criterion for that. But anyways, an objection mill or something that could be worked out, or maybe something that could be answered in a paper, um, right? For example, I can imagine moving faster than the speed of light, even though in this universe it's certainly not possible. Um, so anyways, for now, Mill defines a cause as the set of antecedents on which the effect is invariably and unconditionally consequent. The unconditionally is supposed to deal with this fact of like, we're not just talking about our experience, but any possible situation, um, right? The effect will always follow, right? So day is not the cause of night because it is not, night is not unconditionally consequent on day. We can imagine conditions where it doesn't. Okay, so he addresses briefly the question of, do causes always have to precede their effects, or could causation be instantaneous? Um, Mill's not sure how to answer that, right? He's not sure it matters. It seems to him like most of the causation we perceive is successive, and it would be hard to know if something seemed instantaneous, whether it was just happening over time, but just too quickly for us to perceive it. If you get into quantum mechanics, there might be some sort of instantaneous causation going on in the world of the very, very small. But for him, in the end, he says it doesn't matter. So thinks time is a helpful clue for us as to what's the cause and effect when two phenomena covary, but he doesn't think that causation requires temporal precedence, only necessitation. Um, Now that is like, oof, necessitation is doing a lot of work here, and it's hard to really tell what he means there, right? We've already said it. He can't mean logical necessity. He means some sort of more local, constrained to this universe kind of necessity. Um, But if it's not temporal necessity without temporal precedence, is this just a synonym for causation, right? Is he really explaining anything, or is it just this now a circular definition? Is it? It's not clear how now he's distinguishing causal from logical relations, or is he trying to reduce causal relations to um, something like components, a logical relation? I don't know. Again, if you wanted to write a paper trying to explain Mill for us a bit, feel free. So another sort of objection that Mill considers is the volition theory. So Thomas Reid, another Scottish philosopher, well, the real source of our concept of causation comes from our ability to will. So I'm able to cause happen, right? My body. Hume considered this as well, right? I will myself to raise my hand and it raises, and that's our most basic experience of causation, and then we sort of like import that onto the world. Mill doesn't really see any important difference between those two types of causation. He thinks they're both physical forms of causation, and if you're a physicalist about the mind, then you would have to agree, right? It's neurons firing, right? When my willing is neurons firing, and then my sending the motor commands is more neurons firing, so it's all physical causation. Um, but he also thinks there's not even like an epistemological difference, right? We come to know about causation in ourselves and in the external world in the exact same way, right? So I actually don't have any special a priori knowledge that willing my hand to raise will cause it to raise. He says, I figured that out by experience, the same way I learned about pool ball causation. One ball hits another, that it will move. Um, Example for this, because I don't remember when I learned about causation. I was a baby, right? But he says, imagine that you were like in a car accident and you wake up paralyzed, but you don't know yet that you're paralyzed. And suppose you will yourself to move your hand and it doesn't move, right? You didn't know yet that you wouldn't that causal relation had been broken, right? There's no a priori knowledge of that, and he takes that as evidence that we learn about mental causation of our own bodies in the same way that we learn about causation in the external world, which is by observing. Okay, final objection, and this is one that we're going to have to, be a sort of cliffhanger to try and to fix in future accounts of causation. Right. So again, Mill's account of a cause is this the entire set of necessary and jointly sufficient conditions. And when you have that whole set, the effect invariably follows. It is necessitated. Um, but we've seen that's a huge set, potentially infinite. You also have to include all these negative factors. Um, and he says, yeah, just sorry, deal with it, right? But it seems like maybe it's tough to do science, right? If that's your account of causation, you can never really determine the cause of some event, right? It seems like we would like to be able to make causal claims that are a little more, little less unwieldy, right? Cause-wise, not this giant infinite set of things. Mill can just say, hey, well, you're looking for something that doesn't exist, and it's not his fault that the world is so complicated and causes are so complicated. And if that makes science impossible, too bad for science, right? I mean, he might say that. Maybe you wouldn't want to say that though. Um, so if we, it would be preferable if we could get an account of causation that matches our everyday language about when we talk about causes and individual events causing right, other events that also accords with a scientific practice where we seem to label in causes. That would be better. So Mackey is going to sort of like starting with Mill, fix up his account and provide a version of it that can accords more with our intuitive and scientific practice about causation.